paraphrase you are looking for? Are you looking for this?
Yeah, I think I will be fine.
Okay. Okay, I'm good.
Yeah, I think I'm good.
Okay, welcome the first presenter, Yao Do, and the topic is improving large-scale paraphrasing acquisition and generalization. Welcome him.
So hi, I'm Yao, and I am a second-year PhD student working with Wei at Georgia Tech. And today I will present my EMLP 22 paper, Improving Large-Scale Paraphrase Acquisition and Generation. Yeah. So, so let's think one scenario. So we believe that human creativity is spontaneous. For example, here we can ask annotator to write a paraphrase of a sentence like "It's finally Friday and I'm happy as diverse as possible." So the paraphrase means to write a sentence that has similar main idea. Yeah, and that would be very simple for annotator for just one sentence. Like she can write, "I'm so happy that it's finally Friday." However, if we ask her to write another one, so it's take more time to write one that's totally different from the first one, but it's also doable. And what about another 5, 10, or 20 more paraphrases? That will be very difficult. And so even you have several annotators, it will be still hard for them to write like 10 very diverse paraphrases. Yeah. And yeah. So where can we find some spontaneous paraphrase data? And the answer is Twitter. We can get from Twitter. So every day, millions of people are tweeting about either a trend or talking about some news article. Yeah, like this. And from there, you can get a lot of paraphrase data. Uh, let's take this trend as an example to look at our data collection methodology. So we first group the sentences under this trend or a news article, and then we rank them by the average word probability in the sentence, and then we select the top ranked one. So in this process, we are eliminating the ones that are unrelated to the other ones. Yeah. And then we pair them, so we pair the top two with the rest. And for them here, we have 6 pair, and then we ask 6 annotators to annotate whether the pair is a paraphrase pair or not. Yeah. And so in total, we collect data from about 3,000 trends and 4,000 URLs, resulting in over 100,000 sentence pairs, and 53% of them are paraphrase pairs. Yeah, and so compared to the previous work, our data is much more topic balanced. So the previous work either focused on sports or the majority of the data are about politics, like 2014 election. And so we first do a task, paraphrase identification. It will be useful for like tracking misinformation on Twitter, comparing whether the sentence convey the similar meaning. And so we try bunch of pre-trained large models, fine-tune our data set. Yeah. And conventionally, people just continue use the same data set for paraphrase generation by simply taking out the non-paraphrase data, just use the paraphrase data to train a model to do paraphrase generation, which is useful for like data augmentation. Yeah. But here are some examples. However, there's a problem. For example, these two sentences, these two examples are like two paraphrase pairs because they basically convey the same main idea, except the sentence two contains a little bit more information. And if we just simply use this data for generation, it will make the model to hallucinate. Therefore, we come up two paraphrase definitions. The first one is the one that we collect in the first data set, and then we come a second one which is more strict than the first one. And then we use this new strict definition to collect more data, about 5,000 sentence pairs. Yeah. And because the first data set is really large, we want we want think about some way to incorporate that besides just use a small data set, like with the strict definition, which we call the multi-piece iceberg, and the previous one is called multi-piece cloud. And here the results is you see that the green bar is the model fine-tuned on multi-piece cloud for identification, and it's really bad. So we are trying to leverage some noisy noise training technique. Basically, the idea is we just feed the multi-piece cloud to the multi-piece iceberg, the model train on the multi-piece iceberg model, and we get some probability, and then we just simply flip the label when p is less than some threshold, and then we combine this new data set plus the multi-piece iceberg, and we just train another one student model, and that can perform better than previous ones. Yeah. Yeah, and because Twitter data is continually growing, and then we apply this model to identify paraphrase pairs from 2020 and 2021 Twitter data, and later on we can use this paraphrase data to train a paraphrase generation model, and yeah. So we just get the paraphrase data, and then we call this paraphrase pairs multi-piece auto, and it gets about 300,000 paraphrase pairs. Yeah. And then we train the model on multi-piece auto, and here are some results. So here the score we use is bird eye blue, which is harmonic mean of bird score, and 1 minus cell blue that encourages both semantic similarity and diversity. Yeah, basically T5 large performs the best, and you may ask what about GPT 3.5? And we also tried the zero shot and few shot DaVinci 003, and yeah, so it's not surprising. It's outperformed the fine-tuned model T5 large. Yeah, but we also compare their generation with our data set, and it turns out our data set, our paraphrase pairs is much more diverse than the GP 3.5 model. Yeah, and there's a huge gap in the cell blue. Yeah, and then we are then we are trying to evaluate the dataset generalization, whether the model trained on our dataset can generalize well on the other popular paraphrase dataset. So we can compare our dataset to the other datasets, and we fine-tune T5 large on the other three popular dataset, MS-COCO, Cora, and ParaMT. So the MS-COCO has it's the image caption data, and the captions are paraphrase, and the Cora is a question pairs, whether two questions are paraphrased or not, and ParaMT is collected by machine translation, like back translation. Yeah. So basically here, it's obvious that the in-domain models perform the best, that the model trained on its own data and performed based on its own test set. And but the model trained on MASC-ALL and Cora don't generate well compared to the other two models. And here are reasons because first, the MASC-ALL only contains image captions, so it will make the input to the caption style, not the paraphrase. And for the Quora, it will for the model trained on Quora, it will make the input to a question. Yeah. And what about the case about ParaMT and the multi-pit auto models? And so in the auto evaluation is very similar. Then we do a human eval. Basically, overall, in three aspects: fluency, semantic similarity, and diversity. The model trained on our dataset is better than the model trained on ParaMT, and we also have some quantitative examples. Basically, here you can see our model makes more significant and changes than the ParaMT model, which makes sense because ParaMT is made by back translation. Yeah. And what are the takeaways? So we first utilize the spontaneity in Twitter to collect very large scale and high quality paraphrase data set. And then we separate paraphrase definitions for different tasks, for example, de-identification or generation. And we also saw better generalizability of our models, like the model trained on our data set. And we also have a website for the project. Yeah, thank you.
Okay, thanks, Jorgen. So do you have any questions?
In one of the in the initial slides, you mentioned that about hallucinations, and that was a problem. I'm just wondering that were you tackling that, or were you just mentioning that in the previous data set? You mentioned about hallucinations, right?
Yeah.
Do you do anything to solve that, or?
Yeah. So for that part, that's the main reason why we have two definition for paraphrase, and then we use a more strict definition to collect more data, and we use that data to train an identifier to collect more paraphrase data. So I think we sort of treat that problem by collecting more data that without the problem. Yeah, but we are not solving. We are not trying to tackle that problem in the modeling side. We are just collecting different set of data.
I see.
Yeah.
Okay, any other questions? The last one.
Thank you for the talk. So my question is, in your introduction, you mentioned about generation of X number of paraphrased sentences. And your data set, is my understanding correct that you're just collecting pairs of sentences? One is the primary sentence, the other one is the paraphrase. So the question will be, with that data, can we still generate up to like 10 paraphrased sentences, or does the data set need to be augmented with more paraphrase examples so that the model will learn how to potentially generate, I don't know, up to 20, even more paraphrase sentences?
Yeah. So basically, the model trained on our data set can generate more diverse paraphrase. Basically, you can just sampling multiple times, and it can get diverse, like different paraphrase at each time. So is that what your question? Okay. Cool.
Okay, thank you for your again.